All right, in today's video, I'm going to be talking about two very important parts of any programming language. The first is conditionals. So conditionals allow your program to do something differently depending on some condition. So, for example, in a little diagram here, if x is greater than y, then do something, or if it's not greater than y, then do something else. That's a conditional. Uh, Another important construct in any programming language is the idea of a loop. So this is something you use when you want a program to do something repeatedly. And once we talk about that, we'll also talk a bit about what is good code style, what does it look like, and things like that. You can see there's a little web comic here joking about, so if you've done some programming before, maybe you've programmed in languages that have a go-to statement. So this is something that allows you to control the flow of your program just like a conditional or a loop, but it's not something that's actually in Java, and it's actually usually considered bad style. That's why the programmer here got eaten by the Velociraptor. All right, let's start. So thus far, whenever we had a program, the execution was pretty linear, right? Here's arg's example. It reads in 3 different command line arguments, but if you trace the execution of this program, it would start up here in string product equals arg0. This would be the very first thing the program would do, and then after time step 0, it would go ahead, declare the variable quantity, parse the first command line argument, then go to the next line, declare the variable cost, parse that command line argument, go on to this line, and so on. All your programs thus far have just stepped through linearly through from top to bottom, left to right, all the way through the program. You can do some things like this, but obviously you can't make a very complicated program, and any interesting program usually does not have this sort of linear flow through the program. It's usually more interesting, and conditionals and loops allow us to do that. Basic idea of control flow is you might not execute all the lines. You may skip over some lines, or you may repeat some lines. That's what makes it different. So maybe the program does something different depending on the user input, or depending on the calculations that it does, or something along those lines. Conditionals, when I talk about a conditional, and today we'll look at one particular conditional, the one you'll probably use the most in any programming language, the if conditional. The if allows you to skip some parts depending on a Boolean condition. Loops allow repetition. With a loop you can repeat a section of code or perhaps skip it, so repeat something 0 or more times or 1 or more times. This allows you to do something that's really repetitive without, you don't want to have to like put that same bit of code and have it 10 times in a row. All right, you can put that little bit of code one time and then have a loop that makes it go around 10 times. So the if statement, this is our primary go-to conditional statement in any programming language. So these are not Java specific things. Any programming language you're going to find things like the if statement and the loops we're going to talk about today. How the if works is it evaluates a Boolean expression. So recall the Boolean is a primitive data type in Java, and it's either true or false. We can put something together like x greater than y, or does x equal 3, a plus b plus c, does it equal 0? Any of those things are examples of Boolean expressions. They evaluate either to true or false. If statement is just kind of like in English. If this is true, all right, if the sun is risen, then it's time to wake up. All right, you can have an if, and what we have here are the little curly braces. This is a code block. All right, and inside that code block you can put statement 1, statement 2. I'm just using statement as a general placeholder for some kind of code. An expression is a placeholder for any kind of Boolean expression. You can put whatever you want in here. If this expression is true, statement 1 and statement 2 are executed. Otherwise, the flow of control is going to come to the if, and then if that expression is false, it's going to skip right over that code block that's inside the curly braces. Note the lack of semicolon here. In your programs thus far, you probably got used to always putting a semicolon after every line. This is a case, and this won't be the only case we'll talk about today, where putting a semicolon there is not a good idea. All right, it will either result in a compile error or actually a problem with the semantics of your program. Besides just if, you can also have an else. And so to read this one, if this is true, then we do statement 1 and statement 2. But if this expression was false, then we go and do statement 3 or 4. We either do 1 or 2, or we do 3 or 4. We can never do both of them in this particular setup. In the previous slide, I showed you using curly braces, and you can always use these curly braces to denote a block of code. So something that's kind of atomic. You do all this stuff in there, or you do none of it. If you only have one statement in the if or in your else clause in an if statement, these curly braces are optional. You can write if expression statement 1, if expression statement 1, else statement 2, or you could put curly braces around statement 1 and statement 2 here and just statement 1 here. It would be completely equivalent. And here's the diagram, here's the schematic diagram of this code over here. You see, well, is x greater than y? If so, set the value of max. So remember, equals is the assignment operator. If x was greater than y, then we're going to set some maximum. So imagine we have some local variable called max that tracks the biggest number we found so far. This copies x into max. All right, but if it turns out x wasn't greater than y, that means y is the new max. Then we want to copy the value y into max. Here are some other examples of the if statement in action. If we have some variable x and we want to take the absolute value of it, all right, we can detect if x is less than 0, and if it is, then we can negate it, and that will make it positive. Thus, we'll have the absolute value. We could use randomness in here. All right, this would see, is the random number less than 0.5, and if so, double my money, otherwise I lose all my money. This would be like playing a game where you have 50-50 odds, and if you win, you double your money, otherwise you lose it all. Here's an example of putting x and y in sorted order. We have some variable x and some variable y, and what we end up having happen is have x be the smaller of the two. And we've actually used another variable, t here, a temporary variable, to help us. All right, we copy the value x into t, then we copy the value of y into x, and then we put into y the value that used to be in x. And this will result in x and y being in sorted order. And finally, here's an example of checking something before doing it. So here's the command line args array. And remember, args is normally what we call this thing we pass into the main, and it's an array of strings. It may have 0 or more of the command line arguments. This is testing to see, does that command line have any arguments? If so, then go ahead and convert that first command line argument and put it into the number variable. This will prevent the program from crashing. So this is good, this is good, this is optional, because if there are no arguments in that args array, then doing this num equals line is dangerous and will crash your program. Let's say it's a little more complicated. Instead of having just two options, if this, do that, else do something else, what if we have three options? And here's an example. Imagine we have three category codes. All right, we have an integer category, and if it's 0, it's a book. If it's 1, it's a CD. And if it's anything else, we're going to call it miscellaneous. Here are two ways to do the same thing. We're assigning this local variable title equal to books. So this is a string variable, and it's assigned to books if the category code was 0. If the category code was 1, we assign the string equal to CDs. Otherwise, we assign it equal to miscellaneous. Just like before, if this, we do this code, and then we do none of this else code. Or if category wasn't 0, then we run this code, and inside of this code is another if, which is either going to execute title equals CD or title equals miscellaneous. These code on the left and right both do exactly the same thing. I'd argue this is a little easier to understand and a little better style. We're seeing if category equals 0, do this. else if, we've just kind of moved this if from inside the else block to on the same line with the else. If this, do this. Else if this, do this. Else if neither of these were true, do this. Only one of these title lines will execute. One of the three will execute. No more than one of them will execute, but you're guaranteed if the first one doesn't go and the second one doesn't go, then it's going to do the third one. Alright, so that's conditionals. Let's move on to loops. Here's a while loop. This is a very common way to repeat code. A while loop has an expression, and just like the if statement, that expression is a Boolean. It's like an if, but instead of saying if, we say while, and what's going to happen here is whatever is inside of these curly braces is going to keep going as long as this expression remains true. At some point, hopefully this expression becomes false, and then we drop out of the while loop. As with the if statement, you can have curly braces, you can have multiple statements inside your while if they're bracketed by curly braces, or if you only have a single statement, then the curly braces are optional. If this expression were to be false, alright, so the flow of control is it always starts with the first line, the while expression, and says, is it true? It could initially be false, in which case you're never going to execute this body of the loop. A while loop executes 0 or more times, depending on the expression. It may execute 0 times, 1 time, a billion times, or it might just keep going forever. Depends on what expression and what you're doing in that loop body. Here's an example of calculating something useful using a while loop. This program is going to compute the summation 0 plus 1 plus 2 all the way up to and including n. How high does it count? Well, it parses the first command line argument and puts it into the limit variable. Then I have a counter variable. Traditionally, often we call this variable I. Alright, it's just something that counts, and it's going to count from 1, and we're going to keep counting up until that I variable hits the value n. We also have another helper variable called sum. This variable is going to be the current running summation. We keep looping while that index variable is less than the target limit. Alright, less than that n value we got from the command line. Every time we loop, here's something we haven't seen before. All this is adding the value I to sum. This is basically saying take the value in sum and add I to it. It's like sum equals sum plus I. It's just shorthand for sum equals sum plus I. Every time we loop, we print out what the sum is. Alright, and then importantly, we always increment. This is also a shorthand. What this is saying is this index variable I, make it 1 bigger. If it was 0, make it 1. If it was 1, make it 2. Go up by 1 every time. And this statement here is equivalent to I equals I plus 1. And if you run this program, Java Summation 4, you'll see something like this. Let's go into Eclipse. These examples are on the website if you want to run them yourself. Here's the summation example. Alright, so this is the same code. And I can run it, with the same thing. I can set my command line argument, let's say it to 4. If I run it, I get the same thing I showed you. And what I'm going to show you is how the execution goes using the debugger that's built in Eclipse. So we'll look at the debugger in detail perhaps in a later lecture. But for now, what I've done is I've toggled a breakpoint at this first line of the program. Alright, and then I'm going to go into debug configurations. I'm going to set a command line argument of 4, and then I'm going to debug it. It has a different perspective, so for debugging, if I click yes, it will open up here. And what we see here is a highlighted line in the source code, and this highlighted line is the current point of execution of the program. And on the right, we're going to see any variables that are currently in scope. Currently, there's just the args variable, which contains the command line arguments. And I can step through the program one step at a time by either going up the menu here and stepping over, or hitting F6. we've executed line 10, limit gets the first command line argument, and you can see that it successfully parsed that string and now has a value 4. It's now declared a variable I, has a value 1. It's declared a long, so just a integer that can be really, really big, and it has a value of 0. Now we're at the looping portion. While I is less than or equal to limit, is this code going to execute? Well, you can look over here and try and figure it out. I is currently the value 1 and limit is 4. Is 1 less than or equal to 4? Yeah, that's a true statement, so we're definitely going into the loop. Here's sum gets sum plus I. We're going to add the variable I to the sum. Alright, 0 plus 1 is 1. It'll execute the system.out.println. Alright, if I expand my console window here, you'll see it printed out sum 0 through 1 is 1. We're now on the I++ line. I is currently 1, right? We set 1 up here in line 11. After we execute that line, I is going to be 2. It now loops back to the beginning of the while loop. Is the value of I, that is currently 2, is 2 less than or equal to limit? Limit is 4. Is 2 less than or equal to 4? Yeah. And we loop again. This time we're going to add 2 to the current sum. Now sum is 3. Alright, we print out the next line. I is currently 2. Increment it. Now we have 3. Is 3 less than or equal to 4? Yeah. And we loop again. I is now going to increment to 4. Is 4 less than or equal to 4? Yeah, it is, because we have the less than or equal to, right? Without the equal to, this would have terminated. We do one more time. I is currently 4. I++. I is now 5. Is 5 less than or equal to 4? No, that's a false statement. If you watch what's going to happen now, it jumped past the body of the loop and went down to whatever code was below it. And there's no code below it. And that's the end of the program. You could compute something else. Here's a similar program, also using a loop. Its goal is to compute the powers of 2. All right, it's going to print all the powers of 2, like 2 to the 0, 2 to the 1, 2 to the 2, and it's going to keep doing it as long as the number it's calculated is less than some limit, and that limit is passed in the command line. If you ask powers 2 was 16, it'll print 1, 2, 4, 8. All right, but it won't print 16. And if we ran this in the debugger, you'd see the same thing. It would go run this line, then run this line. It would do this test, and then it would keep looping as long as that Boolean condition was true. Here are 2 while loops. They look pretty similar. Can you spot the difference? This is the good one. This is probably the bad one. That's why it's in red. And there's the difference. All right, my circle is off. All right, but that should be a circle on the semicolon. Be careful. This while loop, just like that if statement, you don't want a semicolon after this. All right, normally a lot of these statements in Java have semicolons, but not the while loop. What you've told Java by doing this is that my while loop is empty. I'll just keep looping while this expression is true and execute like the semicolon, and it won't do anything. And once the while loop terminates, then it'll run the code inside the curly braces, but it'll only run it once. This is almost never, ever, ever what you want. If you got code structured like this extra semicolon is causing you trouble. You almost never want this. So be careful. Look for that. If you have a while loop that keeps, won't terminate, or something funny's going on, you're only getting your body executing once and you're not sure why, you might want to have a look and see if you've got that extra semicolon. It's a very common problem. I see it all the time. Here's another form. So recall that the curly braces are optional. But what's the problem with this? You may think these two are equivalent because the curly braces are optional, but remember, if you have more than one statement in the body of a while loop or in the body of an if statement, you must use curly braces. This guy will not do what you think it does. While I've indented these things, only this first statement, statement 1, is considered in the body of that while loop. Statement 2 is considered to be outside the body of that while loop. Java does not care whether you indent this or not. All right, I care. The person grading your assignments, they care. But Java itself, it doesn't care, and it doesn't use the fact that you've indented statement 2 to tell it anything about what's in the loop and what's not in the loop. Be careful of that. Anytime you want more than one statement, be sure you use curly braces, or even some programmers, even if they're using just one statement, they'll always use curly braces for the body of their loops and if statements. That's okay too if you want to do that. This other most important loop is the for loop. This is a very, very common loop in any modern programming language. Has a for loop. It's a little more complicated than the while loop, but it has some nice features and it's really worth learning about. It has 3 different parts. If you look at the structure, you have the keyword for, and just like the while loop, you have stuff in parentheses and no semicolon. But it has 3 parts that have to be inside of the parentheses. You have an initialization, you have an expression, and you have an increment. How it works is this initialization statement gets run just once. When the for loop starts, this initializes something. And we'll see an example. It's typically a counter variable and you set it equal to 0 or wherever you want your loop to start. Expression is just like the expression in a while loop. It's a Boolean condition, and the for loop keeps spinning around doing its thing until expression is false. And then increment is normally something that increments this counter variable you set up in the initialization. So what the for loop really does is combine some of the stuff. The while loop, either of these loops can do what the other loop can do. You could always use a while loop if you wanted to, but the for loop is a little more convenient, and it combines some of these common things, because often whenever you need a loop, you usually need to initialize a counter variable. You need something controlling how often you loop, and then you also need an increment. The advantage of a for loop is that's all in that package at the top, and you're not allowed to forget any of them, otherwise it won't compile. Just like the while loop or the if statement, more than one statement must use curly braces. Single statement, you can just put it on a line by itself. And just like the while loop, this also is subject to this semicolon problem. Be careful, you do not want a semicolon after your for statement unless you really, really mean it. Alright? This will result in the for loop just spinning and not doing anything, and then executing the body just once the expression is evaluated false. Here's that same summation example. I can achieve the same goal as that other while loop program, but I can use the for loop, and it's probably a little more compact, because instead of having to put this integer variable I outside the loop, I can put it in the initialization section. Alright, I have the same condition controlling the loop, and then the increment I don't have to put in the loop body, I put it up here. Alright, and that's kind of a big advantage, having the increment integrated in the for loop. It means you can't forget to put it there. Alright, if you forget that increment in the while loop, you're going to have a while loop that's broken. And we can go into Eclipse and run the same thing. I can show you, run it through the debugger. We'll do the same. We got 4. Oops, I got to set. Alright, make sure we're set there. Oop, I forgot to set my breakpoint. Got to toggle my breakpoint before I start the debugger. And we're at the top of the program. We set the limit. Alright, we set the sum. And in that one execution, what actually happened in that one step is it assigned the variable I, assigned it to 1. It tested the Boolean condition to make sure it was less than the limit, which it was. Alright, it did not, however, do this. It does this increment once it finishes the loop. It added the sum, it printed things out, and then it's back to the for loop. Alright, it just did the increment, made sure the Boolean condition was still valid. It was still true, so then it loops again. Alright, and so on. And it keeps doing that until eventually this limit hits, the I hits the limit. This is the sort of anatomy of a for loop. You can put stuff before the for loop. So if you want some variable like the sum and you want to use it in the for loop and you want it accessible outside once you're done your calculation, you need to declare your variable outside. So variables are scoped in Java and they only live within their curly braces. If I need this sum after the for loop, like below these curly braces, you don't want to put this guy inside the curly braces. You want to put him above the for loop. That way, after you get done and out of these curly braces, the value you have in sum will still hang around. And as we just talked about, there's an initialization section. Normally you set some counter variable and you set a starting value, a Boolean condition controlling how long the for loop goes, and then your increment operator. This loop does not have to execute, just like the while loop. If this condition starts out being false, then this body, the payload of the for loop, just never gets executed. Final type of looping I'm going to talk about is the do while loop. It's not traditionally used as much as the while or the for loop. So the while and the for loop are the predominant kinds of looping, but the do while loop, I believe, needs a little more love, and so I like to talk about it a bit. And it's very similar to the while loop, other than you start with do, but you don't put the condition up here. You put the condition at the end. All right, and notice actually it does need a semicolon here. Okay, sorry, but if you don't put that there, it's not going to work. All right, the do while, you do need the semicolon at the end. And the main difference with this and the while loop is this loop always executes once. If you've got a particular problem you're trying to solve and it's appropriate always to run the body of the loop at least once, then the do while is kind of your go-to loop. And other than that, it operates just the same as the while. It does this and then it tests the condition, and you've got to remember to do some kind of increment or something so you get out of the loop eventually. Here's a good example of the use of the do while loop. We've got a problem. We want to draw points in the interval 0, 1. All right, and we can do that by just calling math.random, and we're going to keep drawing those random points until we get one that's in some specified interval, left to right. And left to right will be specified by the user of the program as the first two command line arguments. We want to see how many random points we have to draw before we finally get one that's inside of left to right. And the do while is appropriate here because we have to draw at least one, right? You're not going to draw 0 points, right? You must draw one. First it parses the command line, and every loop it's going to draw a point and add one to its little counter, so the counter tracks how many times it's had to draw random points, and keep looping while either the point is to the left of left or to the right of right, right? If it's not in, it has to be greater than or equal to left and greater than and less than or equal to right. If the point is less than left, if it's too far to the left or too far to the right, then we need to keep looping. And this provides a nice simple way to do this. We guarantee the loop goes once, and then the loop will go maybe only once, but maybe many times, depending on how many times we have to draw points. Here are some example runs of that program. If we give it 0.1 to 0.2, it took about 9 random draws. Second time we ran it, it took 2, so we got kind of lucky. It's random, so you're going to get different results every time you run it. If I give it a narrower interval, so 0.1 to 0.11, so that's a smaller slice of that 0 to 1 interval, it took 74 attempts. And then I ran it again with a slightly bigger interval, and I just got kind of unlucky, and it took 198 times to hit one. But what if I did something like this? If I give it the left of negative 0.2 and a right of negative 0.1, I mean, that's a valid interval, but it's not between 0 and 1, right? And our little math.random is always between 0 and 1. it's impossible for math.random to ever return something that's in this interval. This loop will just run forever. Similarly, I could get bad input from my user, and we'll eventually look at, making programs that are robust to this sort of thing. They specified the left and right backwards, in which case it's going to break the program and it's never going to be able to get out of that do while loop. And it's a common problem and one you're going to see as soon as you start doing loops. Sooner or later you're going to create an infinite loop. And what will happen is your program will just never stop. And there's a big red stop button in Eclipse. I'll give you a demonstration here in a sec. Or if you're running something at the command line, which is what we'll look at in the next lecture, you need to hit Control C. And if I load up, do I have here's my draw points program. Alright, and I can set a debug configuration. Alright, and let's say I do the negative version. Alright, I set negative impossible interval. And I got to remember to set my breakpoint before we start this thing. Toggle breakpoint. Alright. Oops. I don't think we ran the right program there. The debugger's a little tricky. Alright. Crying out loud. We want to run this program with these arguments. I think I set the arguments wrong in the wrong program. Alright. Phew. We're finally running. You can see it did the initial setup of the left, the right, and the point. And it's going to draw a point, and it drew 1.135. Alright. But no matter what point I get, none of these points has any potential to be inside of that interval negative 0.2, 0.1. And this will just keep going forever and just print out forever. And if you want to stop an Eclipse, you just hit this red stop button and fix your program. Loops can live inside of other loops. This is a nested loop. Here's a program that prints out little triangles. If you specify 4, it prints out one that has 4 asterisks. We get that limit from the command line. We have 2 loops. We have one loop that's controlled by the variable I and another controlled by the variable j. So these are kind of traditional. If you don't have a good name, I, j, k are often used as control variables in for loops. This for loop on the outside is going to go, if I specify 4 times, this outside loop is going to run its body 4 times. That loop, however, look at what it does. It uses a different variable j. J starts at 0, but j is always less than or equal to I. I is going to initially be 0, in which case j is going to start at 0, and the first time it goes, will it go? Yeah, because j is less than or equal to 0. 0 is less than or equal to 0. It will print a single asterisk. Then it will go down a line. So I don't know if I've shown you this before, but you can have a print statement and you have a print line. Print line, the only difference is print line goes down a line, where print stays on the same line. Second time through the loop, I is now going to equal 1. J is going to start over at 0, and J is going to keep going and as long as J is less than or equal to 1. This time the inner loop is going to go twice and print out 2 asterisks, and then it's going to print a return to go down a line. And then the third time it'll print out 3 asterisks, and then the fourth time it'll print out 4 asterisks. And if we look at that in the debugger in Eclipse, alright, and let's set the debug configuration. Oops, you gotta click on OK. And we gotta remember to set our breakpoint. Alright, there we go. Got it on the first time. And let's switch this over to the variable view. You see we've just started I is 0, and what we're going to see is this loop goes once, printing the single asterisk, and then prints the return. Outside loop then executes, it's still below the limit. Inside loop will now go twice, printing 2 asterisks, then prints a return. Inside loop now goes 3 times, printing 3 asterisks, then prints a return. And then finally it goes 4 times, printing 4 asterisks, prints a return, and then the program's over. Which loop should you use? Well, here's some general advice. If you have some kind of loop that has a counter variable, you've got some integer that goes from 0 up to n, or n down to 0 backwards, for loop's probably your go-to. It's built to have this counter variable. It's very appropriate if you've got a counter variable and you want to always increment or even decrement that counter variable in the loop, and it's hard to forget to put that in there. That's the advantage. If you don't really know how many times you're going to loop, then a while loop's probably more appropriate. And as I said, do while is the least common, but it's a very good loop if you know the loop body has to execute at least once. Let's switch gears and talk a little bit about code style. What do we mean by code style, and what are we looking for? And why do we care? Well, let's talk about, first of all, comments. In Java, you can add comments anywhere you want by putting a double slash. When you put a double slash, anything else on the remainder of that line is not interpreted as program, as it's just whatever you like you can put in there. Well, almost anything. You can put usually some English text describing something. The slash slash is for comments that are on a single line. Once you go down a line, you'll be back into normal programming. If you do a single slash and a star, you start a comment that will run as long as you haven't done the star slash to end it. So if you have a multi-line comment, then this is an easier way to go. Often you'll put comments on a line by themselves, like in this top example, or if appropriate, you might make short comments that go actually after the semicolon. Java just is going to ignore this. You can put whatever you want here. It's not going to cause the program to have a compile error or anything like that. What should you put in comments? Good comments explain why the program is doing what it's doing. Don't comment obvious stuff. All right, I plus plus semicolon. All right, you could comment that and say this is incrementing I by 1. I know that. Anybody that, you can assume the reader knows something about the programming language. What you want to do is comment more high-level stuff, your grand goal of the program, because it's not always obvious as you get more and more complicated programs what a section of code or a particular line of code is up to. I always recommend, if you're about to code something, you're trying to program a bit of your assignment and you're not quite sure what to type in there, it helps to write the comment first. If you write out in English what your plan is, you'll find it's a lot easier to write the code, and you'll probably write the code more correctly. Tricky bits of code always deserve some comments. How do we name things in Java? Variable names, there are some rules of what you can actually use. I'm not going to talk about the exact limits of what you can do with a variable name, but by and large you're going to just use letters and maybe maybe some numbers in your variable names. You can not obey this rule, but in this course we require you to obey this rule, and this is a common Java code standard. Variable names always start in lowercase, and then anytime you get a new word, use an uppercase. Your variable name should be descriptive. It should describe the basic goal of whatever this data is for. In this case, it's tracking how many widgets are in your shopping cart or whatnot. Start in lowercase, uppercase every new word. This makes it easy to read and people to see where the different words are, and is a standard in Java. When you name class files, and you notice whenever we assign, all our assignments, we require you to submit a certain, Java file, and we always name ours like this. You're not required to do this. Java will allow you not to do this, but we require, and good style requires, that you always capitalize the name of the class. So unlike variables, the name of classes always start in uppercase, and then you use lowercase except for the start of new words. The advantage is this allows you to tell the difference. If you've got something that's a class, you can tell just by looking at it. If you don't see this public class, if all you see is inventory tracker, but it's capitalized, it's a class name and not a variable name. Finally, if you've got a variable that can't change, it's a physical constant of the universe, for example, the speed of light, or it's some fixed constant in your program, you tell the world this by using all uppercase. All uppercase, and then of course if you need more than one word, you can use an underscore between the words. This is the standard for declaring constants. The advantage here is anybody that sees this variable speed of light knows it's a constant, and they know they shouldn't go mucking around and changing it, or they might not even be able to change it depending on how you declare it. White space. As I discussed in the bit about looping, Java does not care much for white space. You can put in a space, you can put in 100 spaces, you can put in a tab or 10 tabs or no tabs. It amounts to the same thing to the Java compiler. Here's my star triangle program. It works just like the program I showed you, only I can't read this. Our grader can't read this, and you will make us very grumpy if you submit code like this. It is very difficult for the human to read this, and it's also very difficult for you as the programmer to get this correct. And usually when I'm helping students, the first thing I do, like if they're showing me a program and it's not working and it looks something like this, I say make it look nice. And then usually I don't even have to find the problem for the student, because by the time they make it look nice, they realize what their problem is. It's just programming is difficult enough, so don't make it more difficult by being disorganized. And it's not hard, especially with Eclipse, to stay organized. Let's go look at, here's star triangle, here's star triangle ugly, like the one I just showed you. And Eclipse will help you keep it indented properly, but if it gets really messed up like this, you can hit Control A to highlight everything, and then Control I. And it will more or less, okay, it has some, well, I guess it's got some limits, alright, but really, if we help it out a bit, alright, now we've got some properly. So Control A, Control I will normally sort it out, and if you get it messed up enough like I did, then you're going to have to do some stuff manually, but by and large that will work to help you keep your code looking nice. Normally only one statement per line. Don't go combining, doing stuff like I did here. You can have the semicolon, you could put your whole program on one line, it's just that I don't want to look at it, and don't do that. Blank lines are free. If you've got logical sections in your code, it's okay to put a bit of code here and then have a blank line just to visually separate things. All right, we're all running big monitors with lots of pixels. It's okay to use blank lines if it helps you keep things straight. Just like we have paragraphs in English, it's okay to have different visual blocks of things in your program. Spaces are also free. It gets harder to read if this is a perfectly valid for statement, but it just gets hard to read, and it's easier to read if you put some spaces between things. All right, I hope you agree that it looks easier to parse some of these, as well as I mean it's nicer if you put a space after your slashes when you're doing your comments, so the comments don't run up against the slashes. It's just easier for humans to read. But like anything, don't get too carried away. Okay, spaces are free, but don't get crazy. If things are logically connected, like this is calling the static random method on the math library, you can put a whole load of spaces there, but that's just going to be confusing. Don't go putting spaces everywhere or spaces before the semicolon. Traditionally, people write code that looks like the green stuff. Spaces can also help you spot problems. You can use spaces, and this is just kind of an optional thing, but I think it's helpful in code like this if you space this out so sort of there's parallel constructions in it. So instead of doing this, you do this. All right, there's a bug in both of these programs, but I'd argue it's much easier to spot in this version of the program because everything kind of lines up. All right, space it out like this, but if you've made a mistake like this args, this should be args1, right? That kind of mistake could cost you a long time trying to find, and it's actually often cheaper to just keep your code organized. Mistakes. Where to put the curly braces. You may be surprised to learn there is, a raging religious debate in programming about how you should use your curly braces. There's BSD almond style, which is usually what I use, and there's also a K&R style. The difference is where you put the open curly brace. Do you put it on the line by itself, or do you put it on, the line before that? All right, and I won't enforce my religion on you. I would argue that this is more symmetric and more visually. It takes more vertical space, but it's easier to see the structure in BSD almond style, so that's why I use it in my lectures and why I use it when I program. But if you're, an old hat at programming and this is embedded in your brain, then I'm not going to, we're not going to force you to use BSD almond style. But we are going to force you to choose a style. Don't go switching between it because this is just confusing. No fair mixing and matching. So pick a bracing style and stick with it. If you don't currently have use the top style. All right, just to summarize, we talked about some of the major constructs that we use in Java and in fact in most programming languages. You can create really interesting programs that do very complicated things using just the if statement, just basic loops like the while loop or the for loop, and the idea that you can nest these loops. And exactly which loop you use depends on the situation, and as you become an experienced programmer, you'll get used to deciding, very quickly, oh, I should use a for loop, or no, this is better for a while loop, or oh, I better break out the do while loop for this. All right, you can do anything you can do in one of these, you can do in the others. It's just a matter of what's slightly easier than the other. And finally, we talked about style. Please make your code easy to read. It's good for you. It's good for us. You'll find that's it takes a little more time to produce. Be a little more careful about how you name your variables and how you structure your code. But that will pay dividends when it comes time to making your program actually work correctly. You'll make fewer mistakes when your code is in good style.